Hello class, we're about to start section 10.1, points, lines, planes, and angles. Our objectives. We are to understand points, lines, and planes as the basis of geometry. We're to solve problems involving angle measures, and we are to solve problems involving angles formed by parallel lines and transversals. Okay, now we will have to concentrate on our vocabulary and symbols. Geometry is the mathematics of shapes. The basics of geometry are points, lines, and planes. Now we're going to cover points, lines, and planes. What is a point? In geometry, something having position but not spatial extent, magnitude, dimension, or direction. A point is a position in space or on a plane. Points are usually labeled with capital letters and represented as a small dot, has no length, width, or thickness. Now we come to what is a line. Mathematics, a straight or curved continuous extent of length without breadth, OED. A line connects two points and extends indefinitely. Lines are usually labeled with small letters. Connecting two points along the shortest path. Has no thickness and infinite length. There is only one line that will go through two distinct points. So we have here a line of AB here. A line may be named using any two of its points. Said another way, a line can be named by 2 points that lie on the same line. The order is not important. So we can write line AB or line BA. It means the same thing. Now, it says here a line segment is a portion of a line joining 2 points. A line segment has 2 endpoints. The points between A and B is a line segment. The order is not important. So we have line segment AB, line segment BA. Now just to show a visual representation of this, say we have this segment here. We have an endpoint here and an endpoint here. So this would be A, this would be B. And this is how a line segment goes. You have endpoints here. Okay, so now we have endpoint A, endpoint B. This is how we will list it. Now, we have what is a half line. Any point on the line divides the line into 3 parts, the point and 2 half lines. A half line is formed when a point divides a line. A half line is a ray. See below for definition of a ray with the endpoint removed. Now this right here is a half line. A ray has a closed-in circle, and this has an open circle. It says, what is a ray? A ray is a half line with its endpoint included. It extends indefinitely in one direction. A ray has one endpoint. You see, this is a closed circle. And we have our arrowhead here. Examples of 2 rays. We have point A and B on the ray, and point C and D on the ray, or point D and C on the ray. Rays are named by 2 points on the ray. The first point is always the endpoint. The order is important. When naming a ray, the arrow always points to the right. So now, what happens is your endpoint always goes first. So your endpoint is A here, so the ray would be AB. Your endpoint is D here, the ray would be DC. It says in the diagrams below, a closed circle indicates that the point is included. An open circle indicates that the point is not included, which we have here. These points are included, and this is a line. This point is not included, which is the end point, and this is considered to be a half line. This point is included here, which is the end point and the point on the line, so this is a ray. And then we have a line segment with both endpoints included. Now we come here to what is a plane. It is a flat surface on which a straight line joining any 2 points will wholly lie. An imaginary flat surface through or joining material objects. Relating to only 2-dimensional surfaces or magnitudes, plane and solid geometry. A plane is a flat surface, has no thickness and no boundaries, as we see here. It says here, what is an angle? Now this is very, very important, because we're going to deal with a lot of angles. An angle is formed by the union of 2 rays. One ray is called the initial side, the other ray is called the terminal side. When 2 rays have a common endpoint, they form an angle. The common endpoint is called the vertex. Said another way, the angle is formed by the union of two rays that meet at a common endpoint called the vertex. You see, we have this ray BA and this ray BC, and they meet here at the vertex. Now, in naming the angle, if you notice here, we have, this is angle B here, or also angle 1. So we have 4 different ways we can name this angle. We could call this angle 1, we can call that angle B, or we could call it ABC, and your middle letter is always the vertex letter, or we could go CBA, and your middle letter is always the vertex letter. Now it says here, names for the angle. Angle ABC, angle B, angle 1, or angle CBA. But here we have angle BAC. Now if you look here, BAC, that is not an angle. So it's not an acceptable name. The vertex should be the middle letter. Now, we come down here to this next angle. An angle can be named by its vertex if there is no ambiguity. Now this is the vertex here. There's no ambiguity because this is the only letter here. It's not split or anything for this angle. But we look down here. Now this is ambiguity because we have this angle split. We could do ABC, angle ABD, or we could even do just angle B. But it says if there's ambiguity, then the angle must be named by 3 letters. The middle letter is always the vertex. So we have angle, we could do angle ABC or angle CBD. Now there is another angle that could be listed here. Now we could do angle ABD. That's another angle that could be named here. Now, it says angles are measured by the amount of rotation from the initial side of the terminal side. Angles are measured in degrees symbolized by, you see this little circle here, looks like a little 0, but that's degree. There are 360 degrees in a full rotation, circle. 1 degree is 1 over 360 of a complete rotation. Example, using degree measure. The hour hand of a clock moves from 12 to 2 o'clock. Through how many degrees does it move? Now we look at this problem here. Now if we look at a clock, we know it goes from basically 12 to 12. So there are 12 hours on the clock. Now we want to know the when it moves from 12 to 2, through how many degrees does it move? So we know from 12 to 2 is basically 2 out of 12. So it'll be 2 twelfths, which we know becomes 1/6. Now we have to multiply this 1/6 by 360 because we know it's 360 degrees in a full rotation. So we'll put this 360 over 1, and we'll put our degree symbol. So this will give us 360 degrees all over 6. 360 degrees divided by 6 is 60 degrees. So the degree that this moves is 60 degrees from 12 to 2. Now, we scroll down. It says classifying angles by their degree measurement. It says this is the terminal side, this is the initial side. When the rotation is counterclockwise, the angle is positive. Now it says here, this is the initial side, this is the terminal side. When the rotation is clockwise, the angle is negative. Now, when there is one complete rotation, the angle is 360 degrees. This is the initial side, this is the terminal side. So basically when you travel around and end up at the same place you started, that's a 360 degree angle, or a complete rotation. When there is half of a complete rotation, the angle formed is a straight line. This rotation is a negative 180 degrees. This is the terminal side. This is the initial side. Now, this hyphen here, this negative, it can be a negative 180 or 180 degrees. It depends on the direction of the angle here, where we started from and where we're going. It says when there is 1/4 of a complete rotation, the angle is 90 degrees. This is called a right angle. Now going back here, if we go, I want to go back here. The reason why it's negative 180 is because we're going clockwise. Now if we went counterclockwise, starting from this angle here, and we went this way, then it would be a positive 180 degrees. Now just reiterating what we have below here, it says when there is 1/4 of a complete rotation, the angle is 90 degrees. This is called a right angle. This is the terminal side, and this is the initial side. So you notice we're going counterclockwise, so then that's why this will be a positive 90 degrees. Now, an angle with a measure less than 90 degrees is called acute, which is also called sharp. An angle with a measure greater than 90 degrees and less than 180 degrees is called obtuse or dull. Okay, now, if you look here, this is acute angle less than 90. We already did the 12 to 2, and we know they gave us 60 degrees, which we know is less than 90 degrees, so we proved that. This here is 90 degrees, and this is a right angle. Obtuse, this is greater than 90, because from 12 to 3 is 90. So from 12 to 5 will be greater than 90. And then here is a straight angle. This is 180 degrees. And if you notice, 12 to 5 is less than this straight angle, which is 12 to 6. So that's why this is obtuse. This is more than 90, but less than 180. Now, more vocabulary and symbols. Lines that are in the same plane that do not intersect are called parallel. Now, lines that are not in the same plane will not intersect and are called skew. So that means that these were in two different planes here. Now, planes that are parallel will never meet, but planes that are not parallel will intersect at a line. These two planes here intersect, and they intersect at a line. Now we come here to the protractor. Protractors are used for finding the degree measure of an angle. We measure the angle by placing the center point of the protractor on the vertex of the angle and the straight side of the protractor along one side of the angle. We read the degree by reading where the other side of the angle intercepts the edge of the protractor. Choose the number based on whether the angle is obtuse or acute. Now if we look here, we can plainly see that this is an acute angle. So here, we start here, and we go here. Since this is an acute angle, we know it's less than 90, so we know this top number we cannot use. So this right here would just be 50 degrees. And as you see here, we're going counterclockwise, so that's why it's positive. Now, it says example, using a protractor. Using the protractor, what is the measure of the angle? Now, first of all, we see here that we're going counterclockwise, so we know our answer is going to be positive. Next, we notice that this is an obtuse angle, because if you look here, if this would have been a 90-degree angle, it would have went straight up here. And this is not less than 90 because it would be here. So if we notice, this is obtuse, so we know it's greater than 90, but less than 180. And we notice that we wouldn't use the 70 that's on top. We would use this 110 that's on the bottom. So our answer here would be 110 degrees. Now, we scroll down here. It says examples, using a protractor. Using a protractor, what is the measure of the angle? Now we see this is acute. So we see here that this would be 60 degrees. Now, we scroll down here. It says using a protractor. You notice this is obtuse. We're going counterclockwise here. This is between 130 and 140. So we know this would be 135 degrees. Now we scroll down here to more definitions. Special pairs of angles, complementary and supplementary angles. Complementary angles are two angles whose sum is 90 degrees. To find the complement of an angle subtracted from 90 degrees.